Hello, welcome back to Math with Patrick. Today is February 25th, and we have problem number 56 to solve from this Daily Epsilon calendar. How many primes are less than 100? I think here the best thing to do is let's use a strategy called the sieve of Eratosthenes. And a sieve in math is when you remove certain numbers that you don't want, and kind of like a sieve in real life, it filters out all the small particles or particles you don't want, and you're only left with the things you want. So here we're going to sieve or sift out all of the composite numbers, and we'll remain with all of the primes. Now, let me switch my document so I can get all the numbers from 1 to 100. Here's how the sieve of Eratosthenes works. First, we will start with our lowest number and ask ourselves if it's prime or not. Well, 1 is considered to just not be prime. It's not really like a good multiplicative building block. That's how I like to think about primes, is that they're building blocks to help you build other numbers. 2 and 5 help you get to 10, but the number 1 isn't going to help you build up a number. It'll just do this. It's just the same number. So 1 isn't a useful building block in multiplication, and so in my mind, it's not a prime number for that reason. You could also think that a prime number needs exactly 2 distinct factors, 1 and itself, and these are not distinct. That's another way to think about it. In any case, 1 is not prime, and I will cross it out like that. Okay, let's look at the next number, 2. 2 is prime. You can break up 2 as 2 times 1, and that's it. And there's no other smaller numbers that help compose the number 2 with multiplication. So we found a prime. And here's where the sieve starts working. Any other number that has 2 as a factor is not going to be prime, because I can factor it 2 times something. So all of my even numbers in this grid are all composite. And I can quickly just see that all of these columns produce even numbers. So I'll just cross off all of the columns here. And this way I can sieve or sift out all of my even numbers. And now I just cut out half of my total sample space here. I don't even need to consider any of those numbers now. So this is how the sieve works. And it is pretty quick, at least for small-ish numbers. Once you start searching for primes that are really, really big, there's better strategies. Okay, 3 is another prime. And so I should look for all other multiples of 3 and cross them out. So 6 is another one, then 9, then 12, then 15. But I'm kind of noticing a pattern here. I'll start crossing them off this ways for a sec. Nope, that was a 5. Whoopsies. So I'll double cross off 6. I know it's already composite, but it's also a multiple of 3 too, so I'll just cross it off twice. And then 9, crossing off 12 again, 15. And here's what I noticed, that these multiples of 3 are making diagonals in my grid. And so I could just extend this diagonal further, and I know that I've crossed off only multiples of 3. So same thing is happening here. I have a diagonal of 3, 12, and 21. Those are all multiples of 3. But 3 itself is the prime one, so I'll keep it uncrossed off. So there's one diagonal, another one. Here's another diagonal starting with that 9. And then I'll just keep working my way down this grid. And maybe I'll start looking for multiples of 3 on this right side to help kind of guide my crossing out. And then so there we go. 60 is the next multiple of 3 and 10. So I found it on the side here. And then the final diagonal should have a 90 and a 99. There we go. Okay. And another great thing about this sieve is it just kind of shows you the next prime number. I can already skip over 4 because I know it's a multiple of 2 from earlier. The next smallest number is 5. Nothing below it was able to cross it out, and so therefore it's prime. And I will look for all the multiples of 5 now to cross out. Well, it's really anything ending in a 5 or a 0, but I already covered all the 10s when I crossed them out for the 2s. So it's only this column that I'll have to worry about for my multiples of 5. Now 7 is the next smallest number that wasn't crossed out earlier, so it's the next prime. I don't think it's going to have a pretty picture, so I'll just kind of count up on my 7s. So 7, 14, I'll just cross that off again. 21, 28, 35. And I just kind of realized that the first number that'll actually matter with these sevens is 49. Because I already dealt with all the other multiples of 7 because I already crossed off everything with 2 and 3 and 5. So 7 times 7 is the first new composite number in my grid. And well, let me just kind of count up by my sevens to just keep going. 56, and then 63, and then 70, and oh, okay, cool, 77. So it was worth it to keep going. 84 and 91. Ooh, 91 got me in a previous video. It just looks prime, but it is 7 times 13, so it's a composite number. And last one, 98, which I already crossed off because it's even, but for good measure, I'll cross it off again. And then 8, 9, 10 are all composite because I already crossed them off. And 11 is the last prime number that I am going to think about crossing off other numbers for. So you know how I said like 7, really you only needed to start worrying about the 7 once you hit the 49? And that's because I already dealt with all the smaller prime numbers. So 7 squared is going to be the first number that I will freshly cross off because of 7 being prime. Likewise, 11 squared is going to be the first number that I cross off due to 11 being prime, and that's 121. And that's off the grid already. It's greater than 100. So no other numbers on this grid are going to be composite. I have already crossed off all the numbers I can, and the rest are all primes. And I think that's super powerful. Like it took me like what 4 or 5 primes to cross off this whole grid, and then I'm left with the goodies. Like I'm left with the prime numbers. And so this is kind of that power of the sieve, is that once you just kind of work through the first few, then well, you just have generated all the primes. And as long as I just keep track of the numbers that I've already crossed off and only circle the ones that I have yet to touch, I will have found all of my primes. So give me a sec and I'll circle the rest. We'll count them up and we should get 25 because that's today's date. All right, I think I got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Great. We found all 25 primes, less than 100, and we are all done. Cool. I'll see you tomorrow. Bye.